Welcome to Ask and Learn.
In this problem, we are looking for a plane of symmetry. So we just want to see if these objects have anywhere on them that you can divide them, and it'll be the same on both sides. That'll tell us if it's a chiral. We kind of did this in question 5.1, but this question here, we'll just do it again, looking directly for the planes of symmetry. So you're going to have to deal with my very poor drawings here, but hopefully they will be enough for you to help, or at least to help you see where the planes of symmetry might be on these objects. So the first object that they list is a screwdriver. A screwdriver, I think, generally will have a plane of symmetry just going down the middle. And that's looking at it from the side, or even looking at it if you were looking at it from the top or from the bottom. There would be multiple planes of symmetry, so even if I drew it from the top, which would be just a big circle, or from the bottom, which would be like a point or a line, depending on what kind of screwdriver it is, and then kind of a bigger circle in the back over there. And this would have, since these are circles, multiple planes of symmetry, but the main one, or the biggest one, would be the one dividing it in half this way, that I just drew on top. Now we can look at the baseball bat. Again, same thing. If we look at it from the side, we can see that there is a plane of symmetry going horizontally for most baseball bats, at least. And if we turn it around, again, we would see that they're just basically circles. Again, that will give us basically an infinite number of planes of symmetry since it's just a circle. The golf club. So if we look at it from the side, there isn't really a place for a plane of symmetry. However, if we redraw it and we look at the golf club, looking at it from the front or from the back, generally there will be a plane of symmetry going down. On the left and the right, the golf club should be basically exactly the same. So I think that there would be an axis of symmetry or a plane of symmetry here, looking at it from the front or from the back. For the tennis shoe, again, just looking at the picture I drew, you wouldn't really see a plane of symmetry. And if you even looked at it from the front or from the back, since shoes are right and left, they kind of have like a curve on one side. So there would be a bit of a curve here. So let's say that this is the shoe, and I apologize for my not so great drawing of a sneaker here, but there would be a bit of a curve on this side. And if we were looking at it from a back, the curve would be on the opposite side, but it would still be there, kind of like that. So there would be a bit of a curve here. Either way, there isn't really going to be a shoe that has a plane of symmetry, since again it has to fit to the curve of your feet, so it's uneven. It's not perfectly symmetrical. We look at a car. If we look at it from the side, of course, there isn't really a plane of symmetry here. If we look at it from the front or from the back, or really any way, the car is not going to have any planes of symmetry, since there are just so many parts. So for example, if we looked at it from the front, you'd have the steering wheel on one side. If we looked at it from the back, there would be the exhaust on one side and not on the other. And then from the top and from the bottom, it would depend on what kind of car, but generally it's not going to be symmetrical. There are just too many parts on the car, and there would be something that would be different. Yeah. Moving on to the wood screw. The wood screw is a bit hard to tell just by looking at the picture I drew, but actually since these curves go downwards, not side to side, these screws, they can't be perfectly symmetrical. You can't split it downwards and then have both sides be superimposable on each other because of these slanted curves. They kind of ruin the symmetry there. So there is actually no plane of symmetry in a wood screw. We just did a car, they listed it twice. Finally, we have a hammer. So drawing it, looking at the side, there is no plane of symmetry, but if we redraw it, looking at it from the front or from the back, most hammers, and I'm exaggerating the features here, would be pretty symmetrical. And even if you drew a different kind of hammer, kind of like this, a little more of a simple hammer, this would also be from the front or from the back. It would have multiple planes of symmetry. So we would have, going down the middle, basically for all of these, a vertical plane of symmetry. So yeah, looking at the hammer from different angles at its most simplest form, we can see some planes of symmetry here. So looking at everything that we drew and just talked about, we can see that the things that are going to have a plane of symmetry are going to be the screwdriver, the baseball bat, the golf club, as well as the hammer. These are the objects that are going to have a plane of symmetry, allowing them to be a chiral. So I'm just going to box the answer. And there you have it.